Today we will discuss about circular motion. This is a topic of basic engineering physics, and in every engineering subjects you will find this, in every engineering departments you will find this circular motion as a basic physics topic. So we will discuss about circular motion, but here our this subject of discussion will be totally under the basic engineering physics syllabus. Okay, so we will not just going to discuss JE or something like that because it has got vast syllabus here. So we will discuss only circular motion, of which is regarding the basic engineering physics. So let's start. So starting with the definition. So definition, it is defined as the motion of a particle in such a way that it is always at constant distance from a fixed point, like as we defined a circle. In geometry we define circle as the locus of a point moving in such a way that it is always at a constant distance from a fixed point. Same wise we define the circular motion here. So now suppose here is point O, that the fixed point here, and this particle P starts moving here, and it starts in such a way that it is always at a fixed distance from this point O, and this fixed distance is called the radius of the circle, as we define in the geometry also. So likewise here the particle starts and moves on and make a circular motion here, right? So this was the motion about the circular motion. Now let's see. So before discussing the various terms and more detail about the circular motion, we need to discuss few basic terms here. Okay, so we will start with few basic terms here. So here you can see two different figures. Now for figure 1, suppose at point fixed O and this point 1 P, particle P is at point 1, and it travels linear distance of x. So it reaches point 2 here. Particle P reaches point 2. So since it is at a fixed distance, it will elapse an angle called theta. Okay. And now if you see in this figure, this particle starts from here, reaches here, and it will continue and forms a circle, right? So when it is moving, it always elapses a theta here, angular, and this theta is called angular displacement. Okay, this is the fixed distance r, and this is the linear distance x, which the particle has moved. So you all have studied in the geometry or basic trigonometry that if we consider this triangle OAB on a circular point, then angle theta is equal to arc by radius, right? So here the arc is the length, this x, here the arc length is x, and this radius is r, right? So we get a relation theta is equal to x by r, right? Here x is the linear distance, r is the radius. X is the linear distance which the particle travels, and r is the radius, right? Now if you will see here, we are getting a linear relation between theta, that is angular displacement, and linear displacement. So this is x is the linear displacement and theta is the angular displacement, right? And this r is the radius. Okay, so this was about the angular displacement. Now since we have discussed about angular displacement, likewise in our rectilinear motion or linear motion, we define velocity, and we define it as displacement by time, right? Displacement by time. Same wise we define here also angular displacement, which we represent generally as omega. Omega is equal to angular displacement by time. Angular displacement by time. So this angular displacement here is theta. Theta, like we are considering this motion here only, theta by time. Now this theta can be replaced by this, theta can be replaced by x by r. Now Okay, so this omega can be rewritten as d theta by dt. In differential form we can write it as d theta by dt. Okay, so now this omega is equal to d theta. In place of theta we can replace this theta with x by r, dx by r, right, dx by r, and this is dt. Since r is constant, we can take it out and dx by dt here. And since we define linear velocity as change in displacement by time, change in linear displacement by time, so here dx by dt will be equal to 1 by dx by dt will be equal to v. So omega is equal to v by r, right? So if we will focus, sorry for the mess here, but omega is equal to v by r. Now this omega is equal to v by r is again a linear relation between linear velocity and angular velocity. So we can write v is equal to omega r. Okay. Now we'll again discuss few basic terms here. Now let's see. Displacement, that is theta, and angular velocity, that is omega. Now we will discuss about the angular acceleration. What is this angular acceleration? That is, here we represent this angular acceleration alpha. So as we have defined in linear acceleration, linear acceleration is equal to change in velocity by change in time. Likewise, we can define this angular acceleration is equal to change in angular velocity by change in time. Right. So we know that pi, that is 360 degree, and the time taken is equal to t, that is the time period. So we can write omega is equal to theta by t. So this can be written as 2 pi by t. So t is equal to 2 pi by omega. Right. So this is the relation. These are the basic terms here. Now we will discuss about a term you all have heard about, the centripetal acceleration and tangential acceleration. So we will discuss about centripetal acceleration and we will see what is the quantity which is tending this linear motion to convert into circular motion. Right. So let's start. So here, suppose this is point O and this is the fixed distance R, that is constant radius, and this is the particle P starting from 1 and particle P reaches to point 2. So the angle elapsed is theta. So here, let the velocity vector V1 is equal to velocity vector V1 here and velocity vector V2 here. But the magnitude of these two velocity vector will be same now. Let it be same. So now we can write this here. If we will take this, so we can write acceleration vector is equal to v2 minus v1 by t. Now, this is the generalized equation, that is from here it reaches here, so velocity changes by time taken. Now, let this velocity vectors represented on the velocity this vector triangle. So it will be like this from here. Now this will be the velocity vector somewhere here, and velocity vector v2 somewhere here. So this will be the velocity delta v, velocity vector change in the velocity vectors. Okay. Since the magnitudes are same here, so these sides will be equal. So this is forming an isosceles triangle, and since this angle, this alpha or phi here, if you take phi here, so this will be very small. Phi is very small, so we can neglect this phi and see these sides are equal here. So these two angles will be equal. So for a triangle, this angle should be equal to 180 degree. So this must be equal to 90 degree here, right? So here, now consider this triangle and let's see this case here. This v2 minus v1 can be rewritten as delta v by t. Now if we see the direction of this acceleration a will be the same as this velocity vectors delta v, right? Because in this equation only the acceleration vector and this velocity are the vector quantity, time is the scalar quantity, so it will be having the same direction. But if you see from this triangle, delta v is perpendicular to velocity vectors, right? Delta v is perpendicular to velocity vectors v1 and perpendicular to velocity vectors v2. So this delta v, so this acceleration will also be perpendicular to velocity vectors because it is in the same direction of delta v, right? So it will be always be perpendicular to these velocity vectors at every point, and it always be pointing towards the center, and it will always in the radial direction. So this acceleration here is called the centripetal acceleration because it is pointing towards the center. So we give a name here, centripetal acceleration. Now, with regard then the one more acceleration will come into force, and that acceleration is called tangential acceleration. Like it is defined as when a body is moving in circular motion, changes its speed, that is the velocity vectors v1 and v2 have got different magnitudes, its speed, then it is having an acceleration, and direction of this acceleration is, then it is having an acceleration that is called tangential acceleration, and the direction of this acceleration is along the tangent, that is at every point it will be along the tangent, right? So this acceleration can be defined as v1 minus v2 by t, right? So this is called tangential acceleration, and we have defined as ACP, that is centripetal acceleration, is equal to v square by r. So when a circular motion is taking place, for generalized case, we can write the acceleration as root under at square, that is the tangential square, plus ACP square, that is centripetal acceleration. Okay. So on the basis of this different types of velocity and different types of acceleration, we define circular motion into two different parts, that is uniform circular motion and non-uniform circular motion. Well, centripetal acceleration. But this non-uniform circular motion, as we defined it here as a circular motion in which the speed of the moving particle changes, that is the velocity vector, magnitudes of these velocity vectors are changing. v2 has got different magnitude, v1 has got different magnitude, so it will have ACP, that is centripetal acceleration, that is must for circular motion, and it will have also the tangential acceleration AT here, right? So for centripetal, for this non-uniform circular motion, both the acceleration will be in action. This two the acceleration, tangential acceleration and centripetal acceleration. But uniform circular motion, only ACP will be in force. That's all about circular motion here. Now in the coming video we will discuss about projectile motion.